All right, so today for algebra, we are doing 4.6. So absolute value equations is where we're going. Our objective is to solve absolute value equations today. Trying to straighten that up a little bit. So we're going to be solving absolute value equations, which Cameron was super excited about when he saw that. So I'm stoked that he's excited. Um, okay, so first of all, an absolute value. If you recall, think back, remember when. Okay, the absolute value is the graph's distance from 0. Okay, so the absolute value of -6 is 6. The absolute value of 6 is also 6. Okay. We talk about x. If we have an x in here, okay, if we have an x inside there, we know that it is x if x is greater than 0. But it's also negative x if x is less than 0. So what this means is that absolute value problems will have two solutions. Because if we say the absolute value of x when the variable's inside there equals 4, then x can be a positive 4 or it can be a negative 4. So we say, well, x is actually equal to a positive or a negative 4. But we can write that positive and negative together. Hmm? Oh, jolly gee. Yeah. So if we graph that solution, x can be -4 or it can be 4. We graph both of those solutions. Okay. Any thoughts so far? Okay. Two caveats. If we have the absolute value of x equals 0, that's only one solution. Why is that only one solution?
Because 0 can't be negative or positive.
0 is not negative or positive. It's just 0. Excellent. How about this one? X equal, or the absolute value of x, pardon me, equals -3. That one has no solution because there is no number has a negative absolute value. Like there's no number I can put in here inside here and take the absolute value of it and actually get a negative number. Right? I can put, if I put -3 inside there, what does that equal? 3. I can't get out a negative. Absolute value is never equal to a negative. This is the key, the fact that the absolute value is set equal to a negative. That is impossible. Okay? All right. So let's solve them. Okay. So in this case, again, so we're really always looking for where the absolute value is. Okay, all I have is an absolute value that's equal to 11. So I change this up. Okay, so I'm going to put 1 over here. And I have 2x plus 5 equals 11. And I'm going to put 1 where it's equal to a -11. Okay, and I will solve both of those. All right, so here's the thing. I took this, right, and I did set it equal to -11 because inside here can be 11 or it can be -11 inside of here. Does that make sense? Okay. We're not setting it equal to this 11, but the number inside here has to be 11. So, and then I solve both. So I subtract 5. 11 minus 5 is 6. So I have 2x equals 6. I divide by 2. The 2's cancel, and I have x equals 3 for one option. For my other one, it's a -11, so it's the same thing. I'm still going to subtract 5, but -11 minus 5 is -16. So now I have 2x equals -16. I divide by 2, and I get x equals -8 this time. So my answer is that the x values are 3 or -8. But there's no graphing to do. Woo woo, right? No graphing to do. All right. So let's look at the next one. Here's my absolute values. So the number in here has to equal 18 or what other number? Or negative 18. So that's what we're going to do. We're going to set it equal. So 3x minus 6 equals 18. Or 3x minus 6 equals negative 18. What's the first step?
You would
Add 6. All right, so then I've got 3x equals 18 plus 6 is 24. All right, what's my next step? Divide by 3. So x equals, what's 24 divided by 3? 8. Okay, so there's 1x. All right, let's look at the next one. Same thing, add the 6. Woohoo! So 3x equals negative 18 plus 6 is? Negative 12. Awesome. What do I do next? Same thing, right? Divide by 3. And I get x is equal to? Negative 4. All right, so x equals 8 or negative 4. That is your answer. Very nice. All right, how about C? 8 and negative 8. So we can say x equals plus or minus 8. Because that's 8 and negative 8. I had to give you a simple one, right? Like you're going to see those and be like, wait, what do I do? It's simple, I promise. All right, feeling pretty good? Yeah, I like it. All right, there's some confidence there. Okay, so example 2, we're going to add in a little bit more work to it. How is example 2 different from example 1, actually? Has more stuff, right? Here, we were like, okay, all we had were absolute values. Here's our absolute values, but we also have this plus 5. We got to deal with that first. We don't split until we're down to just the absolute values. Does that make sense? Okay, so let me clear this and move it up so we have more room to work. All right, so again, so I'm going to highlight these because we have all this stuff. So we need to, if we're adding 5, the opposite thing is to subtract 5. All right, in the same time I'm doing that, I'm going to go ahead and combine these like terms. 2y minus 5y, that's where this negative 3y came from. Are we okay with that step?
Yeah.
And then the plus 4 we just kept. So equals 21 minus 5 is 16. Now, we don't have any, we have an absolute value. We have our absolute value equal to a number. So now is when we split. Okay, so then we solve it just like we did A, or example 1. Okay, we've got one that's a positive 16. This one's a negative 16. And we follow our steps. So we subtract 4, divide by a negative 3. We get y equals negative 4. We do the other side, y equals 20/3. There's our answer. So let's do B together. Okay, so again, we've got the absolute value, but we have plus 7. There's our problem. So subtract 7. So we're going to have the absolute value of 2x. Is that minus 3? Yeah. Okay, thank you. Equals, what's 2 minus 7? Negative 5. What do I do now? I split it up. Okay, so Abigail, give me one equation when I split it.
What?
Give me one of the equations when I split it.
2x minus 3 equals
2x minus 3 equals what?
negative 5.
Okay, is something wrong?
No, I don't know.
Why do you sound so unconfident? Like you guys were so sure of it earlier, and now you're like,
What do you mean split it up?
Yeah, like, because now we have the absolute values, right? So we're ready to split it into two parts. Like we did this one, we split it into two parts. I think I lost you.
So it would just be a negative or a positive.
Yeah, so give me one of, like, this was one of the equations, right? That's all I was asking for.
2x minus 3 equals 5.
Okay.
Right? Can you do that?
Yeah.
I don't know.
Right? Can you do that? Can you do that?
Yes.
It's like, can you?
Yeah. And then you do another one and it's 2x minus 3 equals negative 5.
That's just the same thing as that, though. Up there it says no solution. Oh, wait.
Isn't that how it's supposed to be?
I like it. You guys are so right there.
No, just continue.
Nope. We can't continue. You guys have kind of hit it. Why have you hit this roadblock?
It's not a roadblock.
I don't know. Like you said earlier. But I think I understand now.
It is a roadblock.
What? It's just a positive or a negative.
But is it?
I don't know. You tell me. You're the teacher.
I am the teacher. What did I tell you earlier when you had an absolute value equal to this?
It's a positive.
That's not a positive.
You just said it's the absolute value equal to that, so it would be a positive 5.
Okay. But previously in our notes, if I went back up there, or yeah, if I move back up, there were two solutions, right? There were two special cases. X equals to 0 only had one solution. And the absolute value of X equals 0. Yeah, only had one solution. And the absolute value of X equals a negative number. Okay, a negative number is no solution. So that's the thing, is it started off safe and sound. It was equal to 2. When we subtracted 7 and we got this negative 5, there is no solution. There's no number that we can put inside this absolute value that's going to give me a negative 5. Yes, I can get one to give me a positive 5. But it doesn't matter what I put in here. None of them are, like, there's no way that this inside here is going to equal a negative 5. This is no solution.
I think you just set me up for failure.
I did.
I was questioning.
But that's the thing. It wasn't failure. You're like, wait a minute. It feels wrong. But why does it feel wrong, right? Like, that's the thing. And, like, I got exactly what I wanted. I got this feeling of angst and, like, something is wrong, but I don't know what wrong is wrong. I just don't know what to do. Like, I'm frozen in time. You're welcome. I'm glad that you could be my subject today.
I feel personally attacked. I'm not.
You should not feel personally attacked. You should feel privileged that I selected you. Okay. All right, so let's look at that a little bit more. Okay, so we have this absolute value. Again, the absolute value is equal to a negative 3. The negative part makes this impossible. There is no solution.
No solution.
Whereas this one, where the absolute value is equal to a positive 3. Okay, when we're setting these equations, when we're splitting them, we're saying the number in here is either 3 or it's negative 3. Because when I take the absolute value of it, I'm going to get 3. That's why we can set it equal to a negative and solve. Because we're still going to end up taking the absolute value of this number later. Like if I plug these back in. Okay, so if I plugged in x is negative 2. So negative 2 plus 5 equals 3. Well, negative 2 plus 5 is 3. What's the absolute value of 3? 3. That checks out. This one, let's take negative 8. So we're going to have negative 8 plus 5. The absolute value of that should equal 3. So what's negative 8 plus 5? Negative 3. What's the absolute value of negative 3? 3. So this checks out. Because it doesn't matter what number I put in here. What number I put in here, it's always going to be a positive. So it has to be equal to a positive when we're actually, before we separate them. Okay, so then if we look at this, it's going to help us write. The next part of this is writing an absolute value equation. So if I look at the graph here, so x is -2 and x is 8. Where is the midpoint or the middle number?
-5. Wait, what?
Anybody agree with that it's -5?
Yeah.
Yes? Okay. So the midpoint is right here. -5 is the midpoint. So maybe I should write that there. All right. So here's the thing, because we need that midpoint to write and solve. Okay, that's going to be more helpful. So in these examples, they're telling us, like example 1, we're supposed to write and solve an absolute value equation. It's 4 units from 6. They give us the midpoint. Okay, that is the midpoint. So let's go back. How many units from, so this is going to be how many units over is this one? -2 is how many units from the midpoint? So we can go 1, 2, 3, right? So 3, we would write this as 3 units from -5. And if it's the midpoint, truly the midpoint, the other one should be 1, 2, 3 units as well. Okay? So when we're doing this, and then they tell us how many units. So what we do is our midpoint is our x minus the midpoint. That goes inside our absolute value signs. And the units that it is what it's equal, that distance. Okay, because like x is like our origin. Okay, so we're -6 from the origin, and then 4 is the distance, so how far we can go. So in this case, if we solve it, we split it at that point. So x minus 6 is equal to 4, or x minus 6 is equal to -4. We add 6 and we get 10. We add 6 on this side, we get 2. So our x is equal to 2 and 10. This formula might help you. We're taking x minus the midpoint, and it's going to equal our distance. So let's do B. We've got 2 units. What's that? Is that the midpoint or the distance?
That's the distance.
The distance. Okay, from -7. What's -7? The midpoint. All right, so if we do our formula, we're going to have the absolute value of x. What comes next? Minus the midpoint. What's my midpoint?
-7.
So minus -7.
Which would just be +7.
Okay.
Equals 2.
Equals 2. And so, yeah, let's clean this up. Cameron said that'd be plus, so let's clean this up. This is going to be the absolute value of x plus 7 equals 2. That's perfect. All right, so you write me the midpoint or the absolute value equation for C.
Don't we solve it too?
Yeah, we are supposed to solve it. So actually solve this one. Go ahead and solve this one first. Well, first of all, can we solve it? Is it good to solve?
Yes.
Yes. Okay. So we're going to have x plus 7 is equal to 2. And x plus 7 is equal to -2. What do you do? Did you get it?
Yeah. I just did it that way.
Okay. Oh, well, you are going to have to write the equation, though. Because you won't always be given the grade. I mean, like, yeah. So that's the thing. Do write the equation, because there will be on the test where, like, I say, what is the equation? Perfect. And so go ahead and start on C. Okay, you went ahead and did, okay. And then, yeah, we can go back and solve that one. Very good. Excellent. Very nice. All right, so I'm going to show the work while they're working. So then x, whoops, is equal to -5. And we subtract 7 over here. X is equal to -9. Okay, so for B, we should have had x equals -5 and x equals -9. All right, so I'm going to erase this. Well, maybe. All right, Cheyenne, have you done your equation for C? Kind of? Okay. What's your equation? What'd you get for your equation?
You mean like
The absolute value of x.
absolute value x minus 15 equals 5.
Maybe if I can get my pen to work. Okay, absolute value of x minus 15
Yeah.
equals 5. All right, does anybody agree with that?
Yes.
Woohoo! Very nice. Okay, then when it comes, can we split it? It's equal to a positive number. Yeah, we can split it. All right, Cameron, what's one of your equations you're solving?
X minus 15 equals 5.
Okay, and what'd you get for x in that?
I did the wrong thing.
Oh, okay.
X minus 5 equals 15.
Oh, okay.
I got 20.
So I'm redoing it.
You're redoing it. Okay, good. And so you got 20. Can anybody confirm 20? Like we add 15, right? And so we get x equals 20. Good. All right, what's the other equation that we split this into? All right, x minus 15 equals -5. Okay, so we add 15 again. And we get x equals what? -5 plus 15 is?
It would be a -10.
It would not be a -10. It'd be a positive 10. Because you have -5 plus and 15 positives.
Yep, that's what I got.
So yeah, so we'd have x equals 10 and 20. My board keeps wanting to freeze on me today, so we'll let it freeze. That's it! That's all you got today. That's it. Time for homework. Yep. All right. So your homework is, let's see, I'll flip it over here. Page 171, numbers 1 through 35, odd. But that's it for today. Yeah, sorry, just kidding. I'm sorry. I had it all the way down at the bottom, and I thought that was the end of my paper when we paused. All right. So the last one, example 4. Use the average of each pair of numbers to write an absolute value equation. So here's the deal. In this case, you're finding the midpoints. Okay, you are finding the midpoints now. Okay, so if you're given -4 and 10, we're supposed to use the average. What is average?
It's
Added together, divided by 2.
Added together, divide by 2. That's exactly right. So we took -4 and we added it to -10. We divided by 2. So we got -14 divided by 2 is -7. That is your midpoint. Okay. So then if we think about this, we need to know how many units, because we have to go back to this equation, right? We need to know the units or the distance. So if I'm looking at -4 and -10, you could draw a number line to help you. Okay, so -7 is your midpoint. How far is -4 from that? Well, we have -6, -5, and -4. So what's that distance? Or maybe if I go 1, 2, 3, we can see that it's 3 units. Does that make sense so far? Okay, and so then we're going to do that same formula. X minus the midpoint equals our distance. So x minus -7 equals 3. Clean it up to be x plus 7. The absolute value of x plus 7 equals 3. So let's try B. All right, so first we need to find the average of these points. So Olivia, what's the average? How would I find it?
-7 plus 20 divided by 2.
Okay, -7 plus 20 divided by 2. So I've got, again, my board doesn't want to work. So -7 plus 20 is
13.
positive 13. divided by 2. So we've got 6.5. Awesome. All right, so this is my what? Midpoint. It is the average, but it's also the midpoint. So we'll get some random letters in there for midpoint. Okay. All right, so then we need to think, how far is 6.5 from 20 or from -7? So you, okay, she says 13.5. Can anybody agree with 13.5?
Where'd you get 15 over 2?
It's 13.
It's 13. My marker doesn't, my board doesn't want to write, so it keeps glitching out when I'm writing. I'm sorry. So yeah, so 16, so then there'd be 7 to 20. Right, so this jump is a half. 7 to 20 is 13. I'm good with that. Is that what you guys said, right? It was 13.5?
Yeah.
Okay. All right, so our distance equals 13.5 then. So if we go back to that formula, x minus the midpoint, or the absolute value, pardon me, of x minus the midpoint equals the distance. All right, so Cheyenne, what's my formula? Or what's my equation?
It would be absolute value x
Okay,
minus 6.5
good.
equals 13.5.
Ta-da! So you know how to write the equation if you're given the endpoints, okay? And you know how to write the equation previously when you're told how many units it's from the midpoint. So two different ways, but you're using that same formula. The formula to write the equation is always the same. But you have to find the midpoint and the distance to be able to do it. And now that's all. I promise. There's not a second page.
No, there's not.
No, there's really not. Sorry about that, my bad. Life happens.